Heinemann Higher, Chapter 7 on Polynomials, mixed exercise 7k at the end. Last question, another former higher question. Show that this linear term is a factor of this cubic function and find the other factors for part A. Right, well, I'll use my synthetic division then. So putting down a table, I've got coefficients 1, -6, 9 and -4. And if x minus 1 is a factor, then 1 should be a root. So I'll put the 1 into that. 1, multiply it up, add it down -5, multiply it up, add it down 4, multiply it up 4, and I've got a 0. So what I can say now is this. The remainder, I'll have to put formula here, the remainder is 0, which means that x minus 1 is a factor. Because you only get 0 if you divide by something that divides in exactly. So x minus 1 is a factor. And that means I can now reconstruct it. So what have I got? I've got this. F of x was equal to x cubed minus 6x squared plus 9x. Maybe I didn't need to write all that out, but I should write this though. So it's x minus 1 times, and the remaining factor, that's the quotient on that division, the remaining factor is x squared minus 5x plus 4. Factorise that quadratic yourself. It implies in the question that it should do so, so it must be x times x, it must be 1 times 4, the negative goes to the larger, but they're both the same. So that'd be the first part. Fully factorise it. That's it, fully factorised. Maybe it looks a little bit nasty without f of x hanging onto the front of it. Part B, write down the corners of the points where the graph meets the axis. Well, that's a standard. Where does it cut the axis? Easy one first. Where does it cut the y-axis? Well, on the y-axis, x is 0, which means that I just put 0 into that expression. I've got it up there, that's the easy one, so it's -4, which means y equals -4. So that gives me the point 0, -4. Where does it cut the x-axis? Well, if you're on the x-axis, y is 0, so that's this expression here. So that means you've got then that x minus 1, notice that double root, so it's going to be a tangent point on the x-axis there, x minus 1, x minus 4 equals 0, which means x equals 1 or 4. So I've got these 2 points, so it cuts at 1, 0, or rather it must touch at 1, 0, and it cuts again at 4, 0. So there's the points where it cuts the axis. Those are the 2 results I got, the results I got from that. So there's the points where it cuts the axis. Next part. Now part C, find the stationary points and determine the nature of each. Right, so I want to get back to this expanded form. I want to differentiate that then. So that's just going to be 3x squared minus multiply by 2, 12, take 1 off that, and then just the coefficient of the linear term. So I'm going to get stationary points. Stationary points if the derivative is ever equal to 0. If 3x squared minus 12x plus 9 ever equals 0, let's get that common factor of 3 out of there. So it's x squared minus 4x plus 3 equals 0. And then factorise it. So lucky this doesn't require the use of that quadratic formula, because that's just going to be 1, 3, the negative goes to the bigger, but they're both the same. That means something happens at 1 and something happens at 3. And from that you can then find the 2 y coordinates. Now instead of putting them into this formula, it's easier, since we've already factorised it, to put it into this formula. So if x is 1, that obviously comes to 0, and 0 times anything is 0. So there's a stationary point at 1, 0. But you know that anyway because it was a tangent at that root on the x-axis. And if x is 3, it's still easier to use this formula here, because what I'm going to have is 3 minus 1 squared, so I've got 2 squared times -1, and that's going to give me -4 altogether. So something happens at 3, -4. Then, what's the nature of it? Well, make up a nature table then. So something happens at 1, something happens at 3, what happens before, between and after. It's a smooth curve, I don't need to consider the 2 distinct neighbourhoods of it. And I think I'll use my factoring now. 3 is positive, if it had been negative I've had to include it. Well, 3 won't affect the sign. So I've then just got x minus 1 and x minus 3 to work out. Well, when x is 1, it'll be 0, so it must be negative before. and positive after. When x is 3, that's 0, so it must be negative before and positive after. So for f dashed x, it's going to be multiplying the two factors together. Positive 0, negative 0, positive, up, along, down, along, up. No surprise, a standard positive cubic curve. I've got a maximum turning point and a minimum turning point. So I'll just put them here. So I've got a maximum turning point at that and a minimum turning point at that. Maybe in the exam I might take extra time just to write that out fully rather than using the abbreviations. So that was part C. Part D then, sketch the graph. Right, put this information on it. So it's cutting the y-axis at negative 4, the x-axis at 1, 0 and at 4, 0. And it's got a maximum turning point here and a minimum at 3. Well, it's also at negative 4. Right, so it's going to come up, take a turn there, come down, take a turn there, and pass back up there. Something like that. That's negative 4, that's 1, that's 4, and that's at the point 3, negative 4. So that's y equals f of x. Last part. Use the graph, I've got it here, to determine the number of solutions to the equation f of x equals negative x. Now f of x equals negative x is the same as saying, where does this graph cut the graph of y equal negative x, because you're equating the two y coordinates. And the graph of y equals negative x comes through the origin going down the way, so it really just depends where does it come through. It could come through and cut at 3 points, or at 2 if it just slices it, or just at 1. But you'd be able to figure that out by saying, well, what happens with 3? Whereabouts does that line pass with 3? Does it pass above it or does it pass below it? If it passed above it, I'm going to get 3 cuts. If it passes below it, I'm only going to get 1 cut. Well, if x equals 3, then y should equal negative 3. So this graph passes through the point 3, negative 3. It goes through the point that goes through the origin and the point 3, negative 3, which is in here. So when I draw this line, it's going to have to pass through these points, which means that it's actually cutting 3 times. So the answer to part E would be, use your graph to find the number of solutions to the equation. So f of x equal to negative x has 3 roots. That would be question 13.